In this lesson, we're going to keep going with derivatives and spend some more time on the equations of tangents themselves. So the whole idea of a function is it can find us points on a graph. The idea of a derivative is it can find us slopes on a graph. Okay, slope's a different point. So we've got two different functions, one for points and one's for slopes. So be careful which one you're working with. And sometimes it can be a little confusing. We'll take a look at an example of how that can be dealt with. So we've got sand being poured into a bucket for 30 seconds. After t seconds, the weight of the sand is given by this equation. I want to know how the weight of the sand after 10 seconds. So I want to know a specific point on my graph. I want to know S at 10. So everywhere I see a T, you can replace it with a 10. We're going to use our calculators. You can plug all this right into your calculator because it's all ready to go, and your calculator does bed mass for us. If you do it properly, you end up with 4,000 grams. After 10 seconds, we have 404 kilograms. Part B, let's figure out ds dt. ds dt, that's derivative notation. It finds us the rate at which the sand is going into the bucket. So 3 times 0.3 gives 0.9, bring 1 off your exponent. 2 times 18 gives us 36, subtract 1 off your exponent. And 1 times 550 is just 550, and there's no t's left over. There's our derivative. Part C asks us to find and interpret S prime at 10. So again, that's just a different kind of derivative notation. S prime at 10 means let's plug in the 10 every time I see a t, but into the derivative this time. Again, we can punch all that into our calculator just the way it looks, and we get 280. What does that mean? Well, that means in the 10th second, so at t equals 10 seconds, the bucket's weight is increasing. It's increasing, that's a positive, is increasing at rate, that's what derivative is all about, of 280 grams per, I think it's in seconds, right? So grams per second. Okay, this is about rate of change. So if I want to points on the curve, I use my function, my original. If I want to find rates, I use my derivative. Okay. So you can give it a try. For each of the following, explain what we're being asked to find, and then calculate. So see if you can figure out which thing we're looking for here. F at -1 for this function. That means I'm looking for the point. Point, -1, and something. To figure out the something, I can use my original function. -1 to the 4 equals 1. So I've got the point, -1, 1. In B, F prime at 2. That's asking me for the rate when x is 2. I need to use my derivative function. So f prime at x, 3 times 3 makes 9, x, subtract 1 from the exponent. Be careful here, we don't like this divide by x thing, right? So let's fix it. Bring it up to the top. A negative exponent, and negative times a negative makes a positive 2, and x to the -2. Let's find our value now. F prime at 2 will give us 9 times 2 squared plus 2. We can put the x back on the bottom, so it becomes a 2 and becomes a positive exponent. So we'll get 36 plus 2 over 4. So 36 plus 0.5 gives us 36.5. Okay, that's our rate at 2. So our function is really increasing. It's a steep increase at 2. Okay, so the rest of this lesson is going to be all about tangents. Tangents we've talked about are special lines on our curve. Lines that just touch our curve at a single point. The nice thing about those is we can find their slopes and we can find their points using derivatives and functions. We're also going to add in a new line called a normal. A normal is a perpendicular line to the tangent. So if you look at your diagram here, we have our black curve. That's the line that goes up and up and up and up like this. And we're asked or shown that there's two lines just touching. We've got the tangent that just touches at point A. And we've got the normal that goes through point A. And the relationship between the normal and the tangent is they always make a perpendicular angle, which means they make perpendicular slopes. Kind of handy because when we take derivatives, we're finding slopes. So if I know something about a tangent, I know similar things about the normal. I can find their two equations. So the next couple questions, we're going to talk about how to find these equations. So two things you need to know. You need to know, one, the point where it touches. You need to have coordinates, an x and a y. And you need to know the slope, the derivative at some point. If you know those two things, you can find your equation for both the tangent and the normal. Just remember, for the normal, we're going to use our perpendicular slope. Okay, we'll give one a try. So find the equation of the tangent and normal using the following information. So this is a I'm going to draw this first one. I don't expect you guys to draw it, but just so we know what it looks like. Here's our parabola, the standard old parabola, and I want to know the tangent at -1. Okay, I want to know what the equation of this thing is here. Well, equations of lines take the form y equals mx plus b. So I need a slope and a point. Let's start with the point. The point is really easy to find because I have a function that builds points for me. What point do I want to find? I want to find the point where x is -1. So I'm going to put -1 in for wherever I see an x. I'm going to get the value of 1. My point is x -1, y is +1. I then want to do the same thing to find a slope. But I can't use my function for that. I have to use my derivative for that. So for slope, we're going to do f prime at x. The derivative of x squared is just 2x. What slope do I want to find? I want to find a slope at -1. So again, I'm going to put in -1 wherever I see an x. And I get a slope of -2. So now I can start building my equation. My equation is mx plus b, and we'll talk about the tangent one first, okay? So my tangent, y equals m, my slope. My slope is right here. So I can fill that in. To get a b, we need to know a point. Hey, I know a point right here. Y is 1, x is -1. Let's solve for b. So get rid of our brackets, rearrange, and b is -1. So the equation of that tangent is -2x minus 1. Now it asks us for the tangent and the normal, so let's do that next. Our normal is related to the tangent, except for it has the perpendicular slope. So I take my slope again, but I have to do the negative reciprocal. So take the perpendicular, flip it over, and change your sign. So 2 over 1 becomes 1 over 2. It was negative, so I made mine positive. I need to solve for b using a point. What point? The same one I started with. Okay? The normal and the tangent share the same point. So my y value is 1. My x value is -1. And I can get b. Okay, so I can change this to a decimal if you want to. Half of -1 is -1/2. So 1 plus 0.5, 1.5. So my normal is y equals 0.5 or 1/2 x plus 1.5. And I'm totally fine with decimals. All those are nice decimals. And there's lots of parts and pieces involved in that question, but really it's referring back to points and slopes. Okay, let's try the second one. I'm just going to bring this down below here so we can see it easier. We're going to do the exact same thing, but with a more complicated function. I'm not going to worry about drawing at this time. We know the idea here. I want to find the tangent and the normal to this curve at 2. Let's start with a point. The point is 2 and something. How do we get to something? We use our equation. Okay, so 2 cubed plus 2 times 2 gives us 8 plus 4, 12. There's my point. My derivative will get me a slope. So let's get a derivative. We'll get 3x squared plus 2. I want the slope at the value of 2. Everything's about where x is 2, right? So 3 times 2 squared plus 2 will give us 14. Here's my two pieces of information. Let's build ourselves a tangent. A tangent has a slope of 14, and it goes through the point 2, 12. So 2 for x, 12 for y, solve for b. So 12 equals 28 plus b. 12 minus 28 equals b. Negative 16 is b. Our equation is 14x minus 16. I'm going to do the same thing for the normal, except for my slope has to be the opposite. So I need the perpendicular slope. Flip it over and change your sign. So this is going to be a messy one. We're doing fractions for this one. That's okay, not a big deal. We can use our fraction button. Okay, start off with our slope. Plug in the point that we know. Still 212, right? The point doesn't change. The point is the point. So 2 for x, 12 for y. If you want to use your fraction button, you can. You get negative 2 over 14, or 1/7. And we have to add that to the other side, right? And if you use your fraction button, you should get, it's going to simplify it for you. So not a big deal, but you should get 85 over 7 for b. So therefore, your equation is negative 1/14 x plus 85 over 7. And that's the equation of a normal. Okay, tricky stuff there. Guaranteed that you got to be able to do one of these kind of questions. Okay, you have to be able to find me equations and tangents and normals. That's kind of the whole idea of instantaneous rate of change. What's nice about tangents is you can use them to help yourself work backwards. If you know the gradient or the slope of a tangent, you can figure out where you drew the point at. So for instance, if I had this function like this, and I said, where is the tangent 3? I can draw it where it's 3 and say, hey, that one's off by a little bit. Let's pretend it's on there. Maybe it's these 2 points. I can find the points by solving for x. Okay, so for example, at what point on the function, here's my function, does the tangent have a gradient of 2? In other words, where is the slope to? What do we use for slopes? We use derivatives. So what it's really telling us is at some point, I don't know the point, I don't know the x, but I know the slope is 2. Well, we can figure that out if we take our derivative. So take our derivative of this piece right here, and we'll get 2x minus 4. What do I know about this derivative? At some point, it's 2. So let's fill it in and solve what's left. Okay, so we get 6 is 2x, or x is 3. So what's the point where this happens? Well, point is made up of an x and a y, right? So I can find the point by plugging in 3 for x. So 3 squared, 4 times 3, plus 7. Notice I'm using the original function again because I want to find a point, not a slope. I was given the slope in this case. So we get 9 minus 12 plus 7 gives us a 4. So the point is 3, 4. That's where this equation has a slope of 2. And you guys can try the next one. Two functions are given by these two equations. Let's figure where they have the same gradient. In other words, where they have the same derivative. So at some point, their derivatives have to be equal. So if we take the derivative of the first one, 2 times 1/4 makes 1/2. And the 2 part will disappear. It's a constant, right? Derivative of x is just 1. Well, that's a nice equation to solve. 0.5x equals 1, or x equals 1 over 0.5, x equals 2. They're going to have the same gradient when x is 2. If I want to figure out the y that goes along with that, I can use either one of my functions to figure out the y that goes along with that. Okay, and now I didn't ask us for the point this time, so we'll just stop there. It says determine the value. And the value is 2. Okay, so that's the basics of tangents and normals. We're going to try some problem solving, some thinking questions now. So I would pause, try, look back at, see if you can figure these ones out on your own a little bit, and go from there. So I want to find a. The function is given by this equation, and the tangent has a gradient of 2. In other words, the derivative is 2 at the point where x equals -1. Oh, they actually even gave us the point. They're telling us that at -1, our derivative is 2. Let's see if we can figure out a. We can use derivatives. So derivative of x, 2 times, well, it's not a number this time, it's an a. So 2 times a is 2ax, plus 1 times 6 is 6. What do I know? I know this comes out to 2 when I make my x value -1. So I end up with this. And we can simplify it by bringing the 6 over to the left side. So we'll bring that over here. On the right side, I can multiply all this together. I'll get -2a. So I have -4 equals -2a. So a must be 2. I've solved it. A little bit of problem solving. Recognizing the information that I was given. Okay, let's try the next one. The tangent of the function at the point, so they're giving us an x and a y, has a gradient of 9. So I have a derivative at this point. So in other words, at x being -3, comes out to 9. Find a and b. Well, that looks suspiciously like the last question. So let's try the same things. Let's take our derivative. 2 times 3 is -6. X. 1 times a is a. Let's plug in the point that we know. We know our derivative is 9 when x is -3. Hey, I can solve this. 6 times 3 is 18. 9 minus 18 equals a. A's got to be -9. Great, we got that. All we need is a b now. So we're given a function. Our function fx equals -3x squared plus a. We just figured a, right? Let's fill it in. Minus 9x plus b. In order to get b, I kind of need to know a point on this graph. Well, I've been given a point right here, right? There's an x and a y. So my function value, my y, if you will, is 8 when my x value is -3. So let's put the x in for the x, the y in for the y, and solve for b. We're going to expand our brackets, simplify this stuff. We'll get -27 plus 27. That made my life easier. Plus b. B must be 8. Okay, a little bit of problem solving there for you. A bit of thinking. All right, last question. Given a graph, there's an equation. They're telling us the P is the point with an x coordinate of 2. So 2 and something. Don't know the something. We know the tangent at P has a gradient of 1. So if I were to draw this, it's off by a little bit, but we know the slope of that thing is y equals 1x plus something, or minus something. We don't know what it is. But they want us to find a. How can I find a? Well, I know that I have a derivative of 1 at point P. In other words, I know that I have a derivative at 2 that comes out to 1. Okay, this was the x value we were given. We were told the gradient of 1. So let's do our derivative. Y prime equals 3 times a half. It's 3 halves, or 1.5 x squared. 2 times 1 is minus 2x. 1 times a is just a. We know that when we put x in as 2, the answer comes out to 1. So let's see what happens. X in is 2. The answer comes out to 1. So we end up with 1.5 times 4 minus. And we can solve this. We get 1 minus 6 plus 4 is a. So in other words, a is -1. That was helpful. For part 2, they want us to find the coordinates of P. Well, we can find coordinates of any point by using our original function, right? So our original function was y equals 1/2 x cubed. Let's go right down here, minus x squared plus ax, but we know a is actually a minus, so minus 1x, and plus 4. And we want to know the coordinates of P. P is located at the point where x is 2. So we can put 2 in for all our x's. So 2 cubed minus 2 squared minus 1 times 2 plus 4. And you can put that all into your calculator just the way it looks. If you do that, you come out with 2. So therefore, P is the point 2, 2. Okay, so we did A, now we're doing B. Okay, find the equation of the normal at P. So the normal at P goes through P and is perpendicular to the tangent. So what did we say about the tangent? We said the slope was 1 over here. So the slope of the normal will be the opposite. Flip it over. 1 over 1 becomes 1 over 1, and change your sign. So our slope is -1 for our normal. So we can write down right off the bat y equals -1 x plus b. What point does the normal go through? It goes through P. P was 2, 2. So we can put in -1 times 2 plus b, and now we're solving. So we got 2 plus 2 is b, b is 4. Therefore, our normal has the equation -1x plus 4. Okay. Last part. Find the coordinates of the point Q where the normal meets the line again. Now, obviously, I didn't draw mine properly, right? They're telling me it meets the line again. And yeah, it doesn't really look like a right angle. Probably more goes like that or something. Okay, but there's some point Q where our normal hits the line again. In other words, where those two lines are equal. How do we find where things are equal? We do a POI. So our initial equation was y equals 1/2 x cubed, moving up here for a second, minus x squared minus x plus 4. Our normal equation is -1x plus 4. And I want to know where these two things are equal. So let's figure out where they equal each other. One equation, the other equation. Now, something kind of cool about this equation is when I bring all the stuff on the right side over to the left and make it equal 0, we notice that this x cancels with this 4 cancels with this 4, and I'm really left with just 1/2 x cubed minus x squared equals 0. And we can solve this by factoring. Okay? Common factor. They both have an x squared, and we're left with 1/2 x minus 1. You know, this is a quadratics, right? So either x equals 0, or this messy thing equals 0, and just change the half to a 0.5, make our life easier. And we can solve that. 1 divided by 0.5 is 2. These are the 2 points where our curves are equal. One of them we already know. We know the point where x equals 2, because that's the point P. We know this point. The other point is our new one, where our normal re-hit the curve. So we'll call that Q, and it's 0 and, how do I find points? I go back to my initial equation and I put in the value. If I were to put 0 into the initial equation for all the x's, I'd end up with just a plus 4. So Q has the coordinates 0 and 4. And that's a pretty lengthy lesson, lots of stuff in there, tangents and normals. You have to be able to write the equation of both, and you have to be able to work with the equations a little bit, like problem solve, as we did there. The big key is recognize the difference between points and slopes and what kind of information you have. Okay, the homework's a handout for this. Try the questions, come see me if you have trouble, and we can work on them together.